Hello and welcome back. Today we are going to discuss about delta table. Now, we are going to discuss about some utility functions in SQL that would help us with catalogs and schemas, and we are going to look into temporary views. Plus, we are going to look into one of the important topic, which is deep clone and shallow clone. And we are also going to understand how deep cloning is different than the CTAS, which we call as create table as select. Now, before we start with this session, it is very important that you know all the basics about delta table. And I'm not going to cover this again in this series because I've already done this in our previous series, PySpark 0 to Hero. So if you have not seen that video, you just have to go to the YouTube channel Ease with Data. And if you scroll down, you can find the series called PySpark 0 to Hero. Just expand the playlist, go to the bottom, and you can see the videos 28, 29, and 30. This covers everything about delta tables from basics to advanced. And these videos are mandatory before you start with today's video. So if you have not seen this video, I'd recommend you to go back and watch these videos first before you start with today's video. So without any delay, let's begin. Okay, I'm back in my Databricks workspace. I've already created a new notebook called Delta Tables Part 1, and I've selected the mode as SQL, and I've already spin up my cluster. So my cluster is already up and running. Okay, we will start with some utility functions first, and then we will deep dive into temporary views, and then we will look into deep clone and shallow clone, what delta table offers. Okay, so the first one is list catalog. Consider if you want to see what all catalogs you have available. Just to see that, you can just type show catalogs. And if you run this, it will give out all the catalogs that are available for you. Okay. So if you see this are dev external, hive, metastore, all the catalogs are listed, right? But what if you want to search for a particular catalog and want to check if that particular catalog exists or not? So consider if you have 200, 300 catalogs, it is very difficult to scroll through and see whether your catalog present or not, right? So consider I want to see all the dev type catalogs which are available. To do that, you can just add like, and within single quotes, you can type dev and you can put star. Star would be a regex pattern so that it would search any catalog that will start with dev. Okay. So if I rerun this, now you see it only lists the catalog which satisfies your condition, which is dev star. Okay. Now you can also put star in the beginning in order to make sure you are searching for a particular regex pattern. Consider I'll search for something where we have m in between. Okay. So I'll just do star m and I'll put star. And if I run this, it will give me all the catalogs where we have m in the catalog name. Okay. So this is how you can search for different catalogs, or you can list all the catalogs that is available in your Databricks. Now, what if we want to do the same for schema? We want to see which all schemas we have in a particular catalog. Okay. You can just type show schemas in and you can put the catalog name. Consider we want to see in the dev catalog. So we'll just run this and it will show us all the schemas that are available. Same thing, if you want to list a particular type of schema, you can always use the like command. You can just put like and you can put, for example, I want to see all the schemas where we have our name starting with IN. Okay, so I'll just put star and I'll run this. So we have information schema here. Okay. Same thing we can do for tables. So consider if you want to list all the tables, you can just go ahead and type show tables in dev, and just you need to put the schema name as well, right? So we have bronze schema, so I'll just put bronze and I'll remove the like for now, and you can run this. Okay, my bad, we just have to add tables. Okay, so I'll run this. So it will show you all the tables that are present, and it will also give you whether your table is temporary or not. Consider if you want to again use or search for a certain type of table, you can always use the like, and you can put, for example, if you want to see all the tables that starts with sale, right? You can just put sale and you can put a star and you can run this. So it will list you all the tables starts with sale in a particular schema under a particular catalog. Okay, now that we know how to search for tables or how to see the tables or schemas or catalogs in SQL, is it possible to check if a table exists using Python or Spark commands? The answer is yes. So consider if you want to search for a particular table and if you want to see whether that table exists in a particular schema or catalog or not. So to do that, you can just use the PySpark command. So I'll just remove this and I'll put Python magic command because this is a SQL notebook and we want to do it in Python. Okay, so we can just write Spark and we have something available which is called catalog. Okay, and in order to see if a table exists or not, you can just type table exists. Okay, and within single quote or double quote, you can put the complete table name. So consider we have a catalog called dev and we have a schema called bronze and we have a table called sales external, right? Let me expand on the left hand side. So we have sales external, right? So I'll just type sale external. Okay, and if I run this, it would give me an output called true because this table exists, right? Let me add _1 for a table which does not exist. So this table is not present, right? On the left hand side, you can see this table is not present. So let me just rerun this. And now you can see it says false. Okay. So if you want to see if a table exists using the Python or PySpark code, you can always use the spark.catalog library in order to check whether the table exists or not. Okay. So the next thing we will do is we will create a new table called employee. Okay. This is my schema for the table. We are creating the table under dev, bronze, and the name of the table is EMP, and we have around 4 columns in it. Okay. Now, if you see, I have not specified anything. So I've just written create table. So as soon as I do that, this will create a table under dev bronze, right? But we have something available with us, which is called if not exist. So this is something, an extra parameter that you can specify when you are creating table. For example, consider a scenario, you are not sure if this table exists or not. Okay, you don't know if this table exists or not, and you want to create a table and you want to make sure if the table does not exist, it will create the table. If it exists, it will do nothing. Okay, so in our case right now, the table does not exist. So let me just run this. So it says, okay, it means the table is created, right? Let me just refresh here and you can see the EMP table created. Okay, what if you are not sure and you reran this? In this case, it will again say okay, but it will not again create the table because it will just check if the table is not present, then only it will create the table. Okay, so this is something extra that you can specify while creating tables, schemas, or catalogs. For example, if you want to create a schema and if you are not sure whether the schema exists or not, you can just write create schema and you can use if not exist, and you can say under the catalog where dev dot bronze, right? So even if I rerun this, nothing will happen because the bronze schema exists and it will ignore this statement, right? This statement will not fail. Okay, that's the benefit of it. So what if I remove this and I rerun this? This time, if you see, it gives out an error. Okay, this is because the table exists. Okay, so there is an exception raised here. Table or view already exist, right? So if you don't want to run into exceptions and you still want to create a table, and if you're not sure if the table exists or not, you can just go ahead and add if not exist. Okay, so if you run it any number of time, it does not matter. If the table is not there, it will create it. If it exists, it will do nothing. It will just say okay. Awesome. Now that our table is ready, let's go ahead and insert some data into it. Okay, so I'll just click on code and I'll paste some insert query. This will insert some of the employee records inside this table. Okay, so I'll run this now. Nice, it has inserted the data. Let's go ahead and validate. To do that, I'll just go ahead and write select star from, and I'll copy the table name from top and I'll paste it here and I'll run this. Awesome. Now the data is already inserted. You can see all the 4 records are here, right? Now, in a delta table, we can always see the history of a table, right? What are the versions available for this particular delta table? To do that, you can always write describe history and you can specify the table name. Okay, so let me just run this. Awesome. If you see, we have this much history available for this. So first we created the table and then we inserted the data, and this is why we have 4 write operations here. Okay, right now the table's latest version is 4. Okay, if you want to go back and see a particular version, you can always use at the rate v and you can specify the version. For example, if you want to go to the 0th version, which is the first version, right? You can go ahead and run this. You can see there is no data because create table was the first version, right? You can go ahead and see the second version, which is v1, and you can see the first record, right? And if you remove this, you will see the latest version, which is the 4th version. Okay, so this is how it is. Let me go ahead and see the table metadata as well. To do that, I'll just type describe extended and I'll put the table name and I'll run this. Awesome, this is the location where the table data is stored. Okay, so now we know everything about the table that we created. Let's go ahead and create our first temporary view. Now, what are temporary views? Temporary views are something which gets automatically removed as soon as you end your session. For example, if you want to do something about your data, but you do not want to make physical copies of your data, okay, but you also want to remove that particular view as soon as you end your session. So right now I'm using my cluster, right? So as soon as I terminate my cluster, temporary views would be gone. So to do that, I'll just type create and we have to use something called temporary and we have to write view. Okay, and then you just need to specify the view name. So let me just write it as emp view. Okay, and now we need to define a view definition. To do that, you can just write as and you can type select star from and you can specify the table name. Right now, what I'll do is I'll put a filter condition. So I'll do where department code is equals to D101. So this view would be created and it will only filter the data for department 101. Let me just run this. Okay, so let me just go ahead and select star from this view so that you can see the data is there. So I'll just write select star from, and if I go to emp tmp view, I copy this and if I paste it here and if I run this, So you can see the data here for department 101, right? So this view is not storing data anywhere because there is no physical copy created, and that is the benefit of view. Okay, you create an abstract on top of any table based on any query that you specify, and it will act as a table. Okay, but in case of temporary view, it will be lost as soon as you terminate your cluster or as soon as you end your session. Okay, now let's create a permanent view. What if I don't want to lose the view, but I want to keep it always? Okay, so I'll just copy the same query from here. I'll go back here, I'll paste it. Now let's try to create a view for department 202. And this time I'll remove the TMP because this is a permanent view I'm going to create, right? And also going to remove this temporary statement here. But if I create this, this will get created in the default schema. But I need to create this view under our dev bronze, right? So I need to put dev dot bronze. Okay, so let me just run this. Awesome, it says okay. Now if I go and refresh here, you can see EMP view created, and you have a different symbol for view, right? If you can go ahead and run select star from, and you can copy the view from top here, and you can run this. It will show you the data for department 102. Okay, so this is the basic difference between a view and a temporary view. Now if you want to refresh the view and if you want to replace with a different code, for example, I want to change this code for this particular view. To do that, you can just write create or replace. Okay, so what it will do is it will recreate the view with the definition that you change. For example, I'll change the definition to 101, and if I run this now, this view will be replaced. Okay, it will be replaced. Now if I run this query again, you see this view gives you data for 101 because the data is replaced because you have added replace. Okay, but if you don't add a replace and if you try to recreate the view, it will give out an error for you saying that the view already exists. And this is the main difference between a view and a table, that in case of view, your data is not physically copied to a particular location. Rather, view is an abstract for a table for the query that you specify. Okay, in case of a table, if you try to create another table from a table, it will copy the data to a particular physical location. So there will be two physical copies of your particular data, and this is what we are going to see next. Now consider a case where you want to create a copy of your table. It means you want to duplicate the physical data. You want to create two copies of your data. So the simplest way to do is a CTAS command that we called as create table as select. But in select, you specify the condition on which the table should be created. So we already have a EMP table, right? Let's go ahead and create a copy of this table. To do that, we will use CTAS first. So what I'll do is I'll write create table, and I'll name the table. I'll place the table in the same schema. Okay, so I'll write dev dot bronze, and this time I'll write emp underscore CTAS. Okay, in order to specify that this is a CTAS table, and I'll write as, and I'll put the query which is select star from, and I'll copy this again from top, and I'll paste it here, and let me just run this. Awesome, this completed, right? Let's go ahead and see if the data is there or not in this table. So I'll just select this and I'll write select star from, and I'll put the table name, and I'll run this. Awesome, you can see the data is copied, right? Let me go ahead and refresh on the left hand side, and you can see the table is created. Okay, let's go ahead and write the describe command in order to see the metadata of this table. So I'll write describe, and I'll copy this from here, and I'll write extended, and I'll paste the table name, and I'll run this. As soon as I do that, if I scroll down, if I go to the locations, you can see this is a different location from the table that we created. So it starts with 3973. Okay, let me just scroll up to the table EMP. So if you see this, this is the original EMP table, right? It starts with E9678. Okay, so we have already duplicated our data to a different physical location using our CTS command. Okay, so this is what CTS is being used for. Okay, now one more thing, let me just go ahead and show you this. So as soon as I write describe history, and I'll put the table name, and I run this, you can see it starts with version 0. Okay, which says this is a CTAS. Okay, create table as select. Now let's go ahead and see what are the different other modes in which you can clone a delta table. Databricks provide us two ways in which you can clone a delta table with much ease. Okay, the first one is deep clone, and the second one is shallow clone. First, let's talk about deep clone. In deep clone, you can copy both metadata and data. Okay, so consider if you want to create a new table from an existing table, if you have a deep clone done, it means it will copy all the metadata of the table, whether it is partition or whether it is column informations, nullability, anything. It will copy and make sure that the second table is exact replica of the first table in terms of both metadata and data. Okay, and the data would be of the latest version from where you are copying. Okay, now in case of shallow clone, there's a difference. In case of shallow clone, it will only copy metadata, and the data will still point to the original table, to the version from where you have done the shallow clone. Okay, let's start with deep clone. So in order to clone a table with deep clone, you just need to write create table, and you need to specify the table name. For example, we'll do for dev bronze, and in place of this I'll write DC in order to identify that this is a deep clone table. Okay, and we just need to write deep clone, and now we need to provide the table name from which you want to clone. Okay, this is the source table, so we can just use dev bronze and emp. Okay, let me just run this. Awesome, it says the table is created. Okay, so let me just go ahead and first refresh on the left hand side. You can see empdc, which is the employee deep clone table. Okay, so the first thing we will do is we'll check the metadata of the deep clone table. So I'll write awesome, it's a table. Again, if you see, all the metadata properties would be exactly same that of the emp table. Okay, if I scroll down, the location would be different. So if you see, this is at a different location, 4F083. So this is a different location than our emp table. If you remember, our emp table location started with E, right? So it has created a different location where it has stored the table metadata and data. So let's go ahead and see this. So what I'll do is we will go to this location in our Azure portal, and we'll see both metadata and the data has been copied or not. Okay, so I'll quickly go back to my Azure portal. I'll go to storage account. I'll go to ease with data 01. I'll go to storage browser, and then I'll go to blob container, and then to root, and then to metastore. We'll go inside the metastore ID, tables, and then the table, right? Let me just go back, and if you see, it starts with 4F083B9A, right? So this is the one. Let me just expand this. Now if you see, both delta log and the data is available here. So it has just made a replica of your emp table. Okay, so this is how it is. So let me just go ahead and show you the history as well. So I'll just write describe history, and we can write dev.branch.emp_dc. Okay, so let me just run this. Awesome. So if I scroll to the right, if I expand this, you can see it says it is not a shallow clone, and it is from the source version 4, which is the latest version of emp. Okay, so it has made a clone from the table, which is dev branch emp, and it has picked up the latest version, which was the source version 4. Okay, so now this is a complete clone of your emp table. Now comes the question, how it is different from CTAS. CTAS and deep clone does the same thing, but in case of delta tables, deep clone is the much easier option. But in case of CTAS, there is a risk of losing metadata. So there might be some chance that some metadata information like nullability, partition information might get lost when you are doing a CTAS, right? But in case of deep clone, you don't have to worry about metadata at all. Just make a deep clone and the table would be exact replica of the source table. Okay, so that's the benefit of deep clone. Let's go ahead and check what is shallow clone now. In case of shallow clone, if you don't want the data to be copied again, for example, if you want to quickly make a copy of table, but if you don't want the physical data to be copied again, okay, in case of our deep clone, the data is copied again, right? But in case of shallow clone, you don't want the data to be copied again. Only metadata is sufficient. In that case, shallow clone is useful. We will go ahead and create a shallow clone table in order to see how it is different than deep clone. Okay, so I'll just go ahead and copy the command that we use for deep clone in the top. So I'll just copy this. I'll scroll down to bottom and I'll paste this here. Now I'll change the deep to shallow. Okay, and I'll change the name from DC to SC. Okay, to make sure this is a shallow clone. So I'll run this. Awesome, this table just got created. Okay, let's go ahead and see the information about this table. So I'll just copy the table name from top. So I'll first write describe extended in order to see the metadata of the table. So I'll paste it here and I'll run this. Nice, we can see the metadata, right? It is exactly same as emp table. Let me scroll down to the location and expand this. You can see it has created the table at a different location, which is 32 CEC. Okay, let's go ahead in our Azure portal, go back to our tables, and we can see the table here 32 CEC. Let me expand this. Now, if you see, there is no data files inside this because this table is pointing to the data files at the original location on the version you have created the table. So let me just go back to the delta tables and let me scroll down and let me just type describe history here. Awesome. It says version 0. If I scroll to right and if I expand the operation parameters, you see it says shallow as true. And it is pointing to dev branch EMP and the source version 4. Okay. So even if you query from this table now, it is still pointing to the data files of the EMP table. But the metadata is managed at this location only. So if I do a control C of this and if I do a select star from and if I paste it here and if I run this, you can see it still has the 4 records of the EMP table. Now, you might be thinking, what if we update the EMP table? Will that also impact the shallow table? Answer is no. So let me just go ahead and insert one record in the EMP table. Okay. So I'm just going to use this insert query in order to insert a new record inside the EMP table. Okay. Now let me just run this. Awesome. The data is inserted, right? Let's go ahead and do a select star from EMP table. You can see 5 records here, right? The latest record 1005 is also inserted, right? Let me just go ahead and run a select from EMP-SC, which is our shallow table. Now, if you see, it is still giving you 4 records because it is still pointing to the source version, which is 4. Okay, so a shallow table will not be impacted by any change that you do on the main table to which it is pointing. The only problem is when you do a vacuum of the data at the EMP table, then only this shallow table will get impacted. Until that time, shallow table will still be pointing to the source version that you create. What if we try to insert a record inside the shallow table? So what I'll do is I'll just change this to SC and I'll change this to 1006. Now, if you see, it says it is inserted. Let me just go ahead and do a select star from here. And now you can see the 1006 record, right? But EMP table will not be impacted. So let me just go ahead and run a select on EMP table. You see there is no 1006 because this time shallow table had its own data in its location in order to maintain the record that you have inserted. Okay, let me just go back to the Azure portal and refresh the same location where the shallow table is created. Now if you see, there is a data file created. Okay, now shallow table is maintaining its own data. Okay, so if you go back and run a describe history on the shallow table now, you can see a new version created. Okay, if I scroll to right, you can see it is a append mode where it has inserted the data. Okay, so this is how shallow table, a main table, a deep clone table, and CTAS are different from each other. Now, in case of delta tables, delta table provide you a lot of option in order to make your data cloning. Okay, it gives you deep clone, it gives you shallow clone. You can even use CTAS. But now you know all the differences between all the 3 methods. I hope you have learned a lot of things today. In our next video, we are going to look into upserts or merge with delta tables. Till then, keep learning, keep growing, keep sharing.